All right, this video is going to help with section 12.1, which is sampling, frequency, and distribution and graphs. All right, so we're starting our statistics section, and I'm going to show a couple different ways that you can show some technology, I guess. All right, so first thing is this is 12.1. And the first thing that we have to think about when we're doing statistics is what is a population? What is a population? Well, I instantly think people, right? So it is a group in a specific spot, maybe the population of Wyoming or the population of Sheridan or population of the entire United States. But it also could refer to the people in Walmart, could be a population. So it's just whatever the whole group is called, that's our population. So it's a set of all people in a group. Okay, and what would be a sample? Well, a sample is going to be a like a part of that population, okay? So we call it a subset or subgroup of the population. Okay, so when we go to do statistics and we want to say something about maybe Sheridan, so maybe we're talking about the income of the people in Sheridan or something like that. I'm going to need a sample of the people who live in Sheridan. Okay, then I take that sample and do statistics on it. So a sample needs to be easy or random, where each person in the population has the same chance to be chosen as anyone else. So you can't just say, all right, I want to know how many people live in Sheridan, so or I want to know the income of everyone in Sheridan, so I'm going to stand outside of Walmart and I'm going to ask 50 people a question. I can't do that because not everyone had an equal chance to be chosen because maybe they didn't go to Walmart that day. So it's a little bit trickier than that. So we need a random sample, and that is where everyone has a chance to be chosen. Okay, so everyone has a chance. A great example of how to sample everyone in Sheridan is that you send a flyer to every fourth person in the phone book, okay, or something like that. Okay, you go to every seventh house on the street, on every street, everywhere. That would be really hard. Okay, so let's look at this example I have. What if I have a group of casino owners? Okay, so I have a group. Let me put this up a little so we don't see all the other stuff. I have a group of casino owners who decided to survey the city to discover their opinion about gambling. So we are surveying the city about gambling, and we want to decide, are they random or not? So let's look at our first idea. Oh, sorry, first thing is, what's the population? What are we asking about? It's everyone in that city. Okay, population, everyone in that city. If I ask people in a random bar their opinion, so I walk into the bar, I ask their opinion, is that a random sample? No. Why is it not a random sample? Because I did not have an equal chance because I never go to the bar. Too old. They don't let us old people in. Kidding. Okay, so what's another one? I asked people outside of Walmart their opinion. I just said that one, kind of giving that one away. Obviously, you might not be at Walmart, so you don't have an equal chance. So that's still a no. What about if I mail a survey to the last names that start with A? Hell, my last name starts with M. Do I have an equal chance? No. So no, this person is a no. Okay, what if I randomly select neighborhoods? That light kind of hits at that one spot. What if I randomly select neighborhoods and randomly select the homes to survey? Oh, I like that word random. So I randomly did all this stuff. Is that a random sample? Yes. So that's really our only one that was random. Because all the other ones, like a bar, you're going to find people who like casinos, so they'll go for your cause. Outside of Walmart, who knows what you'll get, right? And I don't know if the people with A names like casinos. So you really have to be careful. And this is a big idea for statistics. If you do not get a good sample, you can't prove anything with your mathematical calculations. So you'll have some questions on that, okay? And then we start to talk about distributions, frequency distributions. So what if I have a bunch of numbers and I want to show them a specific way? So let's say I have everybody's grades for the class and I want to present them to my boss on how you did. So I could provide him a frequency distribution. It's just a way to show frequency, which is the number of times each value occurs. So for example, I could have all these grades over here. And what I could do is I could make a chart. There we go. I could make a chart of these and tally them up and find their frequency. So this is called a group frequency, which is kind of common only because it goes from 20 to 29, 30 to 39, 40 to 49, and so forth. Basically, it's like A, B, C, D, F, 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 F. So what we would do is we would see 81 and we would put a tally here. And we'd see 94 and we'd put a tally here. And we'd see 79 and we'd put a tally up here. And we would just go through in order so we don't miss a number. And then we'd tally them up and then we can make our frequency. Okay. So that would be a way to show your grouped frequency. If, I have a different example that's not grouped. I could do a frequency. So I could do a frequency, gosh darn it, I can't remember what this was of. Just a bunch of numbers. Maybe I'll just go with the age someone is. Oh goodness, what would be something, the age someone is at the mall right now, because, I don't know, we don't even have a mall. They'd all be young. I can't remember what the date actually was. So what I could do is I could do my tally, but notice for my tally, they're exact values. They're not grouped. So it just depends on your data. You could have a group for grades that works great, like A, B, C, D, or it could be the exact numbers. I have 7 14s. I have 4 13s. So either one of those is a grouped frequency or just a frequency distribution or frequency table. Okay, it shows frequency distribution, but it's a frequency table. Right, there's 2 of them. I could also create something called a stem and leaf plot of this data here. So a stem and leaf plot, I keep falling off my chair, is going to have stems that are in the tens, or they could be hundreds. It kind of just depends. So basically, I have numbers in the 20s, 30s, 40s, 50s, 60s, 70s, 80s, and 90s. And then on this side, I put the actual number for the 20. So if I look up here in my numbers, the first number I had was 81. So I would go to 8 and put a 1 after it. Then the second number was a 94. So I would go 9, 4. So that 4 represents 94. The next number is 79. Then it goes 86, which is the second one. Sometimes you'll see commas in between the numbers, but typically they're written like I did. So what I like about a stem and leaf is I see my actual values, whereas that grouped frequency didn't show me actual values. I can see the numbers are 29, 32, 55, 60, 66, 79, 75, 74, 81, 86. So just be careful. So we give your whole or your problem in stem and leaf form all the time. Make sure you write them down as 29, 32, not just 9, 2, right? That's not what they are. That represents 29. So that's our stem and leaf plot. Now this, the data I just had didn't work well for a dot plot, but what a dot plot is this data works well for it, is it's a dot above a number, and notice the numbers go in order, just like a number line. There's a dot for each number that is repeated. Can't say that very well. So we had 110, no 11s, but we still include 11. It's a number line. 12, I had 3 12s, 4 13s, 7 14s, and so forth. So a dot plot shows your actual numbers as well, but it's very different from a stem and leaf. Still shows frequency. I can still see 14's the highest. But there you go. There's a dot plot. Okay, so the next kind of graph that I could make is a histogram. Now, a histogram shows frequency as well, and this will be really, really important in stats, and those of you that go on to the stats class. The histogram is my favorite graph for showing frequency. Now, this is a grouped frequency. So this is of the same data we've been looking at. How many numbers are between 20 and 30? There was one, it was at 29. And then there was a 32, so there was one number between 30 and 40. There were no numbers between 40 and 50. And then there was one between 50 and 59. So 60 rolls over to the next one, so you're going to 59 or 69 and so forth. And then there were 2 here, 3 here, and 6 here, and 2 here. This is a histogram because it shows frequency. So we count 1, 2, 3, 4, 5, 6 over here. The bars are next to each other. It is not, I repeat, it is not a bar graph. Okay, a bar graph would have each person has their own bar that goes to their grade. So each bar represents one thing. There's spaces between bar graphs. They aren't shoved together like this. Like, I don't know my actual data from this graph. You will from a bar graph. This, I just see frequency. The most common grade is between an 80 and 90. Right? And then it kind of tails off to the left. We call that left skewed. Okay, tail goes to the left, it's left skewed. Okay, so this becomes important. We also have a frequency polygon, and this is with non-grouped data. So I have my non-group data that I included, and we started with 110, no 0 11s, we had 3 12s, 4 13s, and so forth. So we're just putting a dot where each one is, so it kind of looks like the dot plot, and then I connect the dots. That's what we call a frequency polygon. Okay. So I put a dot on how many on each one. Okay, so most of what we'll do in this class is called descriptive statistics. That's where you're collecting data, you're organizing it in a chart or a table, and you're presenting it in some way. Okay. We also have inference or inferential statistics, and that's where you're making conclusions from your data as well. Okay. So another thing that this section covers is misleading data. So what if I have, give me just a sec. I can't pause my video though because if I pause my video, it'll be in a second video. Misleading data. I know I have a PowerPoint of this. I just forgot to pull it up. Misleading. Okay. All right. So if we look at a couple graphs that I have here. All right, let me do present. Is it going to start? Nope, good. Okay, so if we look at this, take a second, pause your video, tell me what's wrong and why I'm calling this misleading. Okay, so you can pause if you want. Look, first of all, I go from 80 to 90 and then 90 to 2010. That's not counting my tens. One of them's by tens, but then you skip a 10. That's weird. Can't do that. And then look, 1740 is not that far off from this number here. So I'm going to subtract those. So if I took 1080, or 2080, and I subtract 1740, I'm going to get 340. So there's 340 between these two. Now, how many is between these two? So 2392 minus 2080 is 312. So there's 312. So it makes it look like, I mean, it just, the graph makes it look like this one is so much more than this one, which is, oops, so much more than the one before. I want to let me go back. Fine. Anyway, so these are misleading because this one is definitely not like a quarter of this one. So there's other things that you could have noticed about this that makes this graph misleading. So it's just information that's not correct. Okay, here's another one. Let me view this bigger again. Okay, so look at this one. All right, so graph one, we have pizza, hot dogs, and hamburgers, and we start at 9:50. Now, usually you can do like a little squiggly, but excuse me, you can't really just start where you want. You have to start at 0, okay? And then it's showing our difference looks really a lot. Then look here, when we count by a normal graph, we can see the difference isn't really very much. So misleading graphs could be the numbers and how you space them out. So you could do something different and make these two graphs look completely different from each other. So that's another misleading graph. And I think I might have one more. No, maybe I don't. Okay, so I had one other one that was said, but I don't see it on there. I had one other one that was really funny. That, well, I guess my idea funny and everyone else's is probably not the same. Okay, so one thing I want you to consider when you're doing this homework, oh, here it is. Oh, ha, ha. One thing I want you to consider when you're doing this homework is when it makes you pick out a graph, I want you to stop and draw the graph. If you have stats next, you will need to know how to graph or draw these graphs, not just pick one out on my math lab. So I will be making you graph and send pictures to me of your graphs for your next exam. So just know you have to know how to draw them. So try drawing them on your own and then finding the one that matches. All right, I found this one funny. It's itch relief, right? You have 1 minute and then Lanacane and then 60 minutes and then Lanacane. It doesn't really tell you how long this one takes. But it's like, wow, this is 1 minute. This one takes forever. So kind of a misleading graph there. Here's another one. This one's welfare. It's a little hard to read from there. Let me make it a little bit bigger. It's still, it's, you know, a picture of a picture, so it's even still a little bit harder. But on this one, we counted weird here, we counted weird here, and so that made this one look like, wow, we're going way, way up with people and receiving welfare. but really it was misleading. Okay. But check the y-axis. Yeah, so the y was off on that one. This was another one. This was the diminishing financial return of higher education. Totally don't agree with this one at all. So this one says, it's saying like your tuition and room and board are going way up, but what you are earning from getting a bachelor's degree is kind of staying the same or going down. And does this prove that education isn't worth the money? I put worth the money. No, it just depends on what degree you get, on what you're going to make, right? So it's just a misleading graph. I don't even know where they got these numbers, but most people who get a college degree will make more than $45,000. It just depends. And then the cost is a one-time cost for those 4 years or 5 years, how long it takes you. And then you start to make more money. They also counted weird on the bottom, but okay, so I think that's enough misleading graphs. So you're going to be making graphs on this one and talking about misleading and samples. All right.